Okay, welcome to Chapter 2. This is Chapter 2 getting started. Just an introduction to Chapter 2, and Chapter 2 deals with working with graphs. So we're going to be looking at several different kinds of graphs, how to interpret them, how to read them, how to draw them, okay, how to label them. And first thing we're going to do is we're going to talk about the first kind of graph, and that's what's called a bar graph, probably the easiest one to see and interpret and to get information from. So let's look at this bar graph here on the right. You can see it's on a grid, okay, and there's a vertical column and there's a horizontal column or axes, and they're labeled, okay, with information. Obviously this left-hand column here, the vertical axis, is the months of the year, 1, 2, 3, 4, 5, 6 to be exact, and the bottom is number of people. We don't really know what it deals with, but we've got a little bit of information. So what do you think this bar graph might be about? Well, just to keep it simple, it's probably the number of people in a given month. We don't know any more information about that, but that's all we do know. So label the vertical axis and title for the topic you named in Part A. Okay, so label the vertical axis. We'll say that this here is the month. So the vertical axis is right here, so we have to have a label for it. You can see the bottom here, it says number of people. So this is month of the year from January to June. And then it says label a topic. Well, it could be anything. You could pick number of people joining a club, maybe, or maybe some kind of an organization. So we'll just label it saying enrollment in a gym. Okay, we'll just say it's some kind of a gym. It could be anything, okay, but that's just what we're going to name it. Okay, how about, about how many more people were there in April than in the 2 months before? So we're going to go to April, and we see that we have 600 people able. So we go to April, and we look across, and it says there's 600 people. So how many more people are there in April than in 2 months before? Well, what comes before April? March and February. So here we've got 400 and 500, and we're about 450, and then March is 100, that's 550, so April has 600, so we just take 600, subtract 550, and we have about 50 more people in April. How about the 2 months after? So 2 months after April are May and June. So we can see in May we have 200 people, and in June we have, looks like halfway between 300 and 400 is 350. So again, that's 550, so again 50 more because April is 600 people. Okay, question number 2. Rob surveyed grade 11 students. He asked about their favorite type of movie. He recorded the results in the chart on the left. So type of movie, romance, comedy, action, drama, number of students, 9, 21, 24, and 6. Okay, it says create a bar graph for the data. You need to put the categories along the horizontal axis. So the categories are right here, type of movie. So we're going to put them along the axis here. Well, we're just going to say R for romance, C for comedy, A for action, and D for drama. So the first one we'll do is we'll do romance. So I'm just going to put an R right there. And then I'm going to leave a space, and then I'm going to put C for comedy, leave another space, put A for action, leave another space, and then put D for drama. Okay, so that's what we represent. That's on the horizontal. Rob decided to rent a movie to watch with some friends from school. What type of movie would you suggest? Okay, well actually let's create the bar graph first. So romance, there was 9 students. So what we have to do is we have to label this axis here. So we have to look at what is the highest number. The highest number is 24. So we might want to go up by 5s because that'll take us up to here where 24 is. So we'll go 5 and we'll label that as 10, 15 we'll label that as 20, 25 will go to 30. Okay, so now romance, there was 9 students. So 9 is somewhere about here, just before 10. And then we can shade that in. And here. comedy there was 21, so we'll go up to 20 and then just go a little bit past 20. Go down like this, and we can shade that in. Action was 24, so there's 25, so it's just below that one right there. We'll shade that in as well. You can use different colors if you want, if you've got some kind of colored crayons. And drama was 6, so there's 5, so we're just a little bit over 5. Okay, so you want to try and be as accurate as you can. Okay, so we've got number of students labeled on this axis, we've got the type of movie labeled here, and then we've drawn it. So Rob decided to rent a movie to watch with some friends from school. What type of movie would you suggest? Justify your position. Well, I'd say the type of movie would probably be the one that was the most popular for a survey, and that would be an action movie. 24 students chose that. Why? Because it was the highest on his survey. Okay, pretty simple. Okay, look at these definitions on here, data and scale. Okay, make sure you understand them. Number 3, draw a horizontal number line from 0 to 100, label the scale by 20s, then plot 27, 51, and 90. So as you can see up in here on this bar graph, we did the scale by 10s, 10, 20, 30. Well, actually each one of these squares was 5. Okay, so we're going to draw a bar graph, or sorry, a number line I mean. So we'll just draw it to here, and we're going to go from 0 up to 100, and it says label the scale by 20s. So we'll probably say that's 20, that might be 40. Try to get the spaces in between even. This might be 60, there's 80, and there's 100. That's not too bad. And we'll plot 27. Well, that's 20. Halfway between there is 30 because there's 40, 30, so it's just a little bit before that, so I'm going to say that's 27 right there. And it says 51. Well, there's 40, there's 60, 50's right there in the middle, so a little bit past that, so I'll say that that is 51. And then 90, well, that's halfway between 80 and 100, so I'll put it exactly right there and put 90 right there. It's not going to be perfectly exact, but try to make it as close as you can. Okay, calculate each percent of 360. So 15% of 360 just means 0.15, and the word means of, which means to multiply, times 360 degrees, and we get an answer of 54 degrees. 5% of 360 degrees is just 0.05 times 360, and we get an answer of 18 degrees. Okay? Okay, number 5. John works at a camp in Canmore. He used this line graph to schedule events for tomorrow. So here's the title of the graph. It's hourly temperatures in Canmore on July 9th. You can see that he starts roughly at 10 a.m. is where he started recording, and he finished recording at 8 p.m. Okay. On this vertical axis, he has the temperature in degrees Celsius. On the horizontal axis, he has the time of day. Okay. It was 16 degrees Celsius at 9 p.m. Plot this on the graph. So we go to 9 p.m., which is, there's 8, there's 10, so this must be 9, and it was 16 degrees. So you can see the number 16, so we just plot a point right here, and we can connect it with a line like that. Okay. In which hour was the temperature warmest for swimming? So highest temperature looked like it was 28 degrees, and it was between, we start here, we go down to this axis, it looks like 3 p.m. to 4 p.m. So it was from 3 p.m. to 4 p.m. Okay. When did the temperature decrease? The temperature decreased this section right here and all the way down So we started decreasing from 4 p.m. all the way down to 9 p.m. So temperature started going down. So it looks like the hottest part of the day was between 3 and 4. When did it increase? Well, it increased from 10 a.m. looks like to 11. From 10 a.m. to 11 a.m. And it looks like we have another increase. Here it stayed the same. Looks like it's from 1 p.m. to 3 p.m. 1 p.m. to 3 p.m. So look, see, it's not very hard to read and interpret this graph. When did it not change? Well, it's where the line is straight and horizontal, so it didn't change between 11 a.m. and 1 p.m. 11 a.m. to 1 p.m. And then it looks like it didn't change at all between, again, 3 p.m. and 4 p.m. Okay? So this is called a line graph, where before we did a bar graph. Now we're going to get into a circle graph. That's the third kind of graph. What is the measure of the angle in the circle graph? Well, we know that an entire circle is 360 degrees. So if we were to take our calculator and we were to take 360 degrees and we were to subtract these known angles in here, we'll get the one measure of the angle for the unknown one. Minus 36, and it looks like that unknown angle is 162 degrees. Okay? Complete the legend to tell what each sector might represent. So we've got a title. It says types of coins in my wallet. Okay, so we've got 1, 2, 3, 4 sectors, so we've got 4 different kinds of coins. So you could be creative, and we've got pennies, nickels, dimes. Well, not pennies anymore. We have nickels, dimes, quarters, loonies, and toonies. So we could say anything we want. We could say, oh, well, this is the smallest one. I probably don't have that as many as I would like, so 36 degrees might represent toonies. Okay. The next one, which is 54 degrees, that might represent loonies. And C might represent quarters. And A might represent dimes. You might have more dimes than anything else. Might even be nickels, okay? So this is the legend, and it gives an explanation right here. That's the legend, and it gives an explanation for the colors and the symbols in the graph. Okay? Now we've got a different kind of graph right here. So it says, what percent is each rectangle compared to the large rectangle? Well, we need to have a total. So the first thing we need to do is count how many squares there are in here. So we got 1, 2, 3, 4, 5 this way. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 that way. So we want to know the number of squares. We take 5 times 10, and we have 50. So the whole large rectangle has 50 squares. 5 times 10 equals 50 squares total. So let's look for the white ones. Well, there's the white ones there. Out of 50, 2 are white. So we have 2 out of 50, which is the same as 1 out of 25 if we simplify the fraction. And if you want to know what percent that is, you just take 1 divided by 25. So we'll take our calculator, do 1 divided by 25 equals, and we multiply that by 100 to get a percent, because that's what a percent means, out of 100, and the answer is 4. So that is 4%. So that means 4% of this entire rectangle right here are those 2 white squares. Black, we have 2, 4, 6, 8. So we have 8 out of 50, which is the same as 4 out of 25. So we take our calculator. We'll do 4 divided by 25. You could also take 8 divided by 50. It doesn't really matter. Get an answer, and we're going to multiply that by 100 because we want a percent. And it's 16%. So that means 16% of this entire rectangle right here is black squares. Light gray. right here. 2, 4, 6, 8, 10. So we have 10 out of 50, which is the same as 1 out of 5. And 1 out of 5 is 20%. Okay, that's a little bit of mental math you can do in your head. You don't need your calculator every time. Spotted, that's all of these ones over here. So it looks like we got 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5 times 5 is 25. So we have 25 of those squares out of 50. Well, we already know that's half. So that's going to be 50%. Okay? Striped. 1, 2, 3, 4, 5. So we have 5 out of 50 are striped. Okay? And 5 out of 50 is the same as 1 out of 10, which is equal to 10%. Okay, now, if we've done our mathematical calculations correctly, when I add all of these up, they should add up to 100% of the square. Okay? So the whole large rectangle we know has to equal to 100%. So let's add these up. I've got 10 plus 50 is 60, plus 20 is 80, plus 16 is 96, plus 4 is 100. So here, all of those add up to 100, which they should. Okay, so that's getting started. And the next one we'll do is we'll get on to 2.1, which is going to be bar graphs in detail.